Welcome to Maths and Science by IITian channel. In this lecture, I will be taking up a very important typical question on permutations and combinations useful for both IIT JEE and also Maths Olympiad. Maths Olympiad and IIT JEE. Here we are not involving Pascal's theorem. It is a very different theorem other than Pascal's theorem. Don't mistake it to Pascal theorem. Pascal theorem, it will have on right hand side n plus 1. We don't have n plus 1 here. All the values are n. NC_R1, NC_R2 and NC_R3. What is the question? NC_R1 plus NC_R2 plus NC is equal to NC_R3. We have to solve this question. Pascal's theorem is different from this. We can apply Lucas theorem. If you have heard of it, it will be better. Otherwise, how to apply Lucas theorem in this particular question, I will explain you. It's a different type of question. It's not a normal question. Please try to understand that. It's not a regular question, it's a typical question. It will have multiple solutions and we have to find out what is the pattern of n, what is the pattern of R1, R2 and R3 in the combinations when NC_R1 plus NC_R2 is equal to NC_R3. N is same in both the cases. R1, R2, R3 are different. R1, R2, R3 are different. R1 is not equal to R2 is not equal to R3. This is our condition. Let us solve the question. What is the question? Solve for R1, R2, R3 where it is given that NC_R1 plus NC_R2 plus NC_R3, sorry, it is not plus, it is equal to NC_R3. We will go for the solution. What is NC_R1? Factorial n by factorial n minus r into factorial r. NC_R2 factorial n by factorial n minus r2 into factorial r. And what is NC_R3? Factorial n by factorial n minus r3 into factorial r3. These are the values from the elementary combinations and permutations. You can easily understand how I have written this. Now, using the Lucas theorem, I will give a just simple solution to it. Please remember the Lucas theorem solution. Don't worry about anything. We will treat the Lucas theorem in detail in the next lecture. N is equivalent to 2 mod 3 For small values of n, if you apply this n equivalent 2 mod 3, then we will be able to get the solution. This is Lucas theorems, not direct definition, it is a Lucas theorems observation. From the observation or derivation of Lucas theorem, we can say n equivalent to 2 mod 3. Let us try to apply it. Then shall we get a solution for R1, R2, R3 such that R1 is not equal to R2, R2 is not equal to R3. Let us try to solve. 1. N equivalent 2 mod 3. Let us take one example. What is that example? Which one shall we take? Let us take a 2 digit. N is equal to 11. Shall we take? Let us take example. Let us try how to get the values of R1, R2, R3. N is equal to 11. That implies 11 equivalent to 2 mod 3. 11 minus 2 is divisible by 3. Then this equation, how it can be written? NCR1 plus NCR2 is equal to NCR3 can be written as 11CR1. Think this equation is not applicable for all n's. We are trying the values for n equivalent to 2 mod 3. Here n is equal to 11 we have taken. We cannot take any n value and solve this. 11CR2 is equal to 11CR3. If you go for any value of n on real line, you may not get the solution, a general solution. But for certain values of n, such that n equivalent to 2 mod 3, for some values of n, you will get the solution. Now here I have taken n is equal to 11 because n is equal to 11 satisfies n equivalent to 2 mod 3. Now let me check whether left hand side and right hand side both are same or not. What is the value of left hand side? 11CR1 plus 11CR2 is equal to 11CR3. That implies factorial 11 divided by 11 minus R1 factorial R1 plus factorial 11 divided by factorial 11 minus R2 factorial R2 is equal to factorial 11 by, this is 11 not h, sorry, 11 minus R3 factorial into factorial R3. Then what will be the possible values? What are the possible values for which this equation is valid? Let us say, here we were told R1 is not equal to R2 is not equal to R3. Here it was told, given condition is that R1 is not equal to R2 is not equal to R3. For n is R1 is equal to 3. Let us try. R1 is equal to 3 and R2 is equal to 8 and R3 is equal to 4. Let us try what happens. R1 is equal to 1 means what is happening? Factorial 11 by R1 is 3. 11 minus 3 is factorial 8 and factorial 3 plus factorial 11 by factorial 3 factorial 8, that is equal to factorial 11 by factorial 7 and factorial 4. Let us see whether it is valid or not. Factorial 11 by factorial 8 is how much? 11 into 10 into 9. 11 into 10 into 9 divided by factorial 3 is 6 plus 11 into 10 into 9 divided by same thing 6, that is equal to 2 into 11 into 10 into 9 divided by 6, then 2 3s are 3 3s are. That means left hand side is equal to 11 into 10 into 3. 110 into 3, 330. Now what will be the value of factorial right hand side? Factorial 11 by factorial 7 into factorial 4. That is 11 into 10 into 9 into 8 divided by 4 into 3 into 2 into 1. 4 2s are 3 3s are 2 get cancelled. 3 into 11 into 10. 330. Cross check again. When R1 is equal to 3, R2 is equal to 8 and R3 is equal to 4, all are different. They are not equal. All are different. That means this is a valid solution. Please cross check again. Cross check. Do your mathematics. Do the mathematics. And cross check. And you see whether it is a correct solution or not. 11 into 10 into 9 by 6, 11 into 10 into 9 by 6, 2, 2, 3, 3, 3 ja, 11 into 330, 11 by factorial 7, that is 7 is gone, 11 into 10 into 9 into 8, then factorial 4 is 4 into 3 into 2 into 1, 2, 4 2 ja and 2 2 gone, 3 3 ja, 3 into 11 into 10, yes. Now, one solution is R1 is equal to 3, R2 is equal to 8, R3 is equal to 4, where R1 is not equal to R2 is not equal to R3. Your homework is to find how many such R1, R2, R3 can be possible for n is equal to 11. Similarly, shall we take some other value of n? That you do. There are many values of n for which R1, R2 and R3 can be found out. Homework is find all values of n up to n is equal to 100 so that the above equation is satisfied. How many n's are there? Count them. Next class we take the same example and see. Question is how many n's are possible. 2. Sum of the n's possible. N is such that n is less than or equal to 100. Sum of possible n's for n is less than or equal to 100. These type of questions you can expect either in Maths Olympiad or in IIT JEE examination in permutations and combinations. And we will do different. I here give different types of ideas and problems to you which can be solved in different methods and apply them. Whichever is easily done by you, understand them, understand the concepts and apply them and do better in the examination. With this concept, I want to close this lecture. Best of luck to everybody. Thank you for listening to me. In the next lecture, I will be solving how many number of n's are available, what are their values and sum of the n's applicable for this particular question when n is less than or equal to 100. Very good question, very nice question. Please try to understand it and apply it. Thank you for listening to me. Thank you for viewing this lecture. Best of luck to everybody. If you feel this lecture added some value to your knowledge, kindly share and subscribe to my channel. Maths and Science by IITian. Thank you. Best of luck.